Simplified are a set of guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Hello.
Hello, sir. How are you, sir?
I'm very good. Are you good?
I'm also good. I'm doing well myself.
Academics, bruh.
Yeah, ish.
Uh, we all have different stresses in life, but for everyone, whatever you are going through at that moment, for when it's big deal, and other people are not mara oliena. It's just great, mang. Mara for you, that's your biggest rock or your biggest mountain that is in front of you, which you have to move. So I was thinking, since I started late, I I wanted to tell you first, Tori, before I add other people. This lesson we can rotate it around functions. For today, we're gonna do our question of chemistry when we get our one.
Ish. Oh, okay.
Or rather, is it because you were having some ideas of when I writing chemistry?
I'm writing chemistry in 2 weeks' time, but I'm writing maths next week. So,
Okay, fine. Let's do it like this. We don't have to do functions. Let's look at what you are like. Answer say before I add anyone, I want to decide with you what topic are we going with, so I can choose people who need such topic. Because I
uh,
didn't do lesson. I started with again.
I think mainly trig, because the paper next week is based on trig and Euclidean, and I'm good with Euclidean. It's just trig, and it's like
Trick.
trig without the trig functions.
So mainly under trick, which part do you think this one is the one? So we do questions similar to that.
Number one is finding the value of k. Like when they say sine is equal to 42 degrees, and then you have to put it in terms of k. Um, Also a bit
So
of co-functions.
basically finding the general solution.
Not the general solution. It's like a whole different question where they say express this in terms of x, and then sometimes you have to use the diagram. The
Do you
diagram.
have the type of questions? Maybe you can send me a picture.
Okay, yes.
Yeah, let's do that. Let me just I don't know
And
if I
then
was
the other questions would be co-functions.
four functions, like for a case where you have to draw two functions of trigonometric identities in a graph and show where they're interacting and stuff. That's what you mean by co-functions.
Yes, like where you have to change it to class 90, 10, 90. Yeah.
Oh, oh, when you have when you have cos 90 minus this, and then you have to set it to cos.
Yes. What happened to my trick book? What's right there?
Right. While I'm waiting for a question, let me also open an ideal past paper just to have.
Oh yeah, I sent it to you. I mean, honestly, I don't know. Oh, also, obtuse angles. I don't know if it's called obtuse angles, where the angle should is like greater, and then you have to make it. No, when it's like an what is it called? When it's a big angle, then you have to make it an acute angle to solve.
Picture that you sent me. I see. Just and what is stressing you, it shouldn't be stressing. It's not that much of a big deal. So it's about having an angle. Maybe you have if sine, it's sine what? The sine 19 degrees. For the image that you sent me, below the your note, your pink note, the problem that we have below there.
Oh, I was muted. I meant it's if sine 19 is equal to k, yeah, write the following in terms of k, basically.
Think about something which actually we have someone joining. Welcome, welcome, welcome. At least like everyone is gonna learn something. So now what you have here, do it since I can't share the screen, this one we're gonna do it traditional.
Okay.
So uh so you don't even have to think deep, because you already know how to play around with your thingy. So I'm just gonna go straight to it to show you with confidence. So you have sine 19 degrees, it equals to k.
Yes.
What you know, sine theta is equals to y over r, opposite over hypotenuse.
Yes.
And any number is over 1.
Oh,
Since
yes.
any number is over, means I can say r is 1 and then y is k. So I can go and construct my diagram and put 19 degrees there.
Would this also work for like the first part that I showed you? Like the first
Now,
question A.
I'm gonna go to question A. I didn't really look into question A, but this one I just feel like it's gonna be quicker to understand
Okay.
because you already been applying this in other forms for those you have been doing this, but it's just that you were doing it with numbers, not with variables.
Mm.
So since sine 19 is opposite over hypotenuse, it means it is opposite over hypotenuse fair. So meaning to complete your triangle, you still need the value of x in terms of k.
Mm-hmm.
So the value of x in terms of k, you have to work it out first, and then that would be r squared is equals to x squared plus y squared. Therefore, x squared is going to be r squared minus y squared. Therefore, x squared is going to be 1 minus k squared, but we are looking for square root. Therefore, square root of x. So therefore, x is going to be square root of 1 minus k squared. So this will be square root of 1 minus k squared.
Yes.
Yeah, I mean, your representation now, it's up to you, whatever they say. So now, the first one, they gave you cos 161. It's up to you. Like for the first one, they gave you cos 161. So for cos 161 is then how you can figure out how do I relate 19 degrees to 161. So I can see where you already did say it's the same as cos 180 minus 19 degrees. Because if you take 180 minus 19, you will get 161. That's why we put it like this.
Okay.
Because literally 108 minus 19. So whatever angle you choose this side, it must be the same angle that gives you the value of what it was before. You don't just pick. So it's easy to manipulate it because you are following the fact that whatever I put there, it should be based on that angle. And whatever way, like how whatever presented, they will make sure it is like that. Like you would have an angle. It's either 108 minus, or sometimes it could have been 90 plus, or whatever it may be, but it will link you to the value based on the special angle that you have. You see that? But
Yes.
according according to your thingy, in your Cartesian plane, you know that in your Cartesian plane, if this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant.
Oh, it would
We
be in
know that
quadrant 2.
here we know that it's 90 degrees minus x theta. Here is 90 degrees plus x as well as 180 degrees minus x. Here is 180 degrees plus x as well as 270. Here is 270 degrees plus x as well as 1 plus. So this part is something which you probably either you know now, or it's something which you would make sure that you push to know as because it's just a revision again. So
Yes.
it's still at 2 in that quadrant is cos positive or negative or what. So cos of 108 minus x is on the second quadrant, and on the second quadrant, cos has to be negative. So because
Negative.
cos, so this means this will be negative cos of 90 degrees. So negative cos of 19 degrees, according to your diagram, cos is adjacent over hypotenuse. So this will be negative adjacent 1 minus k squared over hypotenuse, which is just 1, but it doesn't really matter. So the answer is just going to be negative square root of 1 square root of 1 minus k squared. So it is the very same theory that you used to do with the diagram. It's just that when in a previous grade, you were doing it more of numbers only. Now they just changed. They put variables instead of numbers. So you just have to put it in terms of those variables, but still the same application. Hence, that's the very same story that I'm saying. These guys, the educators or the people who are responsible for setting the exams, what do I call them, Ghana? The exam board. Okay. Fact that you know these things, when they pull it in a different way, you feel like, hey, now, here we go again. Mathematics is complicated. It's the very same story of grade 1. They used to put a box plus something is equals to whatever the value may be, and then grade 8 they put x, they remove the box, they put x, and then you just feel like but I understand because things get bigger and bigger and bigger because of the whole thing. Mara, we can do it in any different form. Let me see the number 1a, the one you say is gonna work throughout segment. For the number one
I-
A, they were just teaching you for the A1, they were just teaching you how to do the thing. Oh, I know probably someone would be asking, where do we get this number A or number B? Don't worry, I will share the one that we are doing. It's just that I have a picture on my phone. And if I send the
Okay.
picture, it's probably not gonna it's probably make sense to you. So I'm just taking the important part the important parts from the page. But don't worry. So all I was saying, the first one, they were just teaching us this part here. Like they were teaching us how to get used playing around with this part, how to choose your angles. Or when
Mhm.
just a matter of if you have cause what, how can you make it to fall? Because all you need to do, whatever angle you have, your manipulation must be such that it must either be 90 minus, 90 plus, 180 minus, 180 plus. So it must always play around 93, 180 to 70. It cannot be any other number that you are not familiar with, because whatever number you have, you must end up using it under this condition. Ne? So
Mhm.
all the time, whatever is given to us, the manipulation is like that. So let me get a different one. Let's put in the way they had cos. Okay, now we are done with this part. We can remove this part, ne?
Yeah.
Sure. We're gonna try to find another example again, maybe from a past paper. But before that, let's look at the first one. Say they gave us cos 160 degree. Cos 160 degrees, you must write it in the form of an angle that makes sense. Oh, this one, let me take it all of it. So they were saying if cos 20, if cos 20 degrees is equals to t,
Mm.
write the following in terms of t. So the following that they gave us, I'm going to put them down here. The following that they gave us was cos 60, cos 160 degrees, and then we have cos of minus 200 degrees, and then we have sine of 250 degrees, and then we have sine of 20 degrees. Then we have to write all these in terms of t. First of all, the most important thing is your diagram.
That's the bit. The reason I was confused is because the first part they didn't use a diagram, and then the second part they used a diagram. So.
Yes, but your responsibility to just use the diagram because you want to visibly see what's going on.
Mm-hmm.
And always stick to the fact that any number is over 1. So you'd be able to know what cos of theta will be will be x over r. So in this regard, you already know that your r is 1, your x is t, and then you go and put 20 degrees there. Cos is adjacent over hypotenuse. And then, yes.
Yeah.
Oh, I thought someone is asking a question. Okay, good. Now, to continue from here, we can now calculate the value of y before we complete, because we don't know, we may need our y and stuff from this. So therefore, r squared is equals to x squared plus y squared. Therefore, y squared will be r squared minus x squared. Therefore, y squared is going to be 1 minus t squared. Therefore, square root. Therefore, we know that y will be square root of 1 minus t squared. So that means y is square root of 1 minus t squared. But we are not done. So here, they gave us cos 160. We must manipulate our cos 160 to fit in the standards of sine 90 degrees minus x, 90 degrees plus x, 180 degrees minus x, 180 degrees plus x, 270 minus x, 270 plus x, 360 minus x, and then 360 plus x. Now, we need to meet these standards while we are manipulating these numbers. For the first one, to get 160, matter while we are manipulating them, we must consider 20 degrees. They must relate to 20 degrees because we want to use this diagram. So whatever it is, I must, like my guidance is that these values, they allow me to say either 180, 90 plus, because it works like that. For instance, cos 160 is simply the same as if I say, because if I take 180 degrees minus 20 degrees, I will get 160.
Oh, yes,
Also
yes.
this one, yes. So I'm gonna do them one. Let me write this on the side. Okay, since we calculated R, I can remove this part. Let me just move this here so I can use the space for calculating one. Great. So now I'm just gonna move it down here because there's no equal sign here. So I will say this is cos of 180 minus 20 degrees because I want to match it to this angle while I'm using the right rule to convert. So 180 minus 20, again, it's cos, second quadrant. Cos is negative, so this will be minus cos of 20 degrees. Therefore, if it's minus cos of 20 degrees, therefore be minus t. And then the next one.
Oh, okay.
Let's have cos of minus 20 degrees. Cos of minus 20 degrees should remind you of cos of minus theta.
Mm-hmm.
What is cos of minus theta?
This is not negative cos theta.
Which quadrant is cos of negative? Which quadrant is negative theta? Remember, according to your story, you still know, they would say to you, all students take coffee.
Mm-hmm. So quadrant 3 for 200 degrees.
Never mind the 200. Just, okay, between the two, which one is which? Negative sine theta and negative cos theta.
Negative sine theta would be quadrant 1. I mean, quadrant 2 and 4.
So think of it like this. When we go positive theta, we go from here, we go this side.
Mm-hmm.
Okay, even if I don't say theta, I can say x. Positive x is this side. And then negative x, we are going clockwise. So when I go clockwise, the first negative if I go negative, I'm on the fourth quadrant. And on the fourth quadrant, cos is positive, but sine is negative. I'm talking about just the negative part of it only.
Mm-hmm.
So cos of negative 200 is the same as cos of positive 200. That's how I get rid of the negative, because I applied this rule. It falls under things that you must just put yourself for it. Even if I don't look at it like that, but I just have to know the cos of a negative angle is a positive angle. It's there on the beginning rules. It's probably there on the what's this, on the table of those instructions that they give us. but it's just that it is the fourth quadrant because we are looking at like this, we are going back. But it's not about the value first. It was just about the angle itself, just to manipulate the negative inside to end up having this. So if I have this, then I can say this is the same as, which one is closer to 20 that I can manipulate here? I want you to choose between 90 plus 20, 180 plus 20. Which one would give me 200 if you manipulate?
180 plus 20.
180 plus 20. So this would be cos of 180 plus 20. 180 plus 20, it's what number? It's which quadrant?
3.
It's cos positive there.
No.
So this would be minus cos of 20. Since cos of 20,
It's negative t. Okay.
so Obana Hakiri, you are stressed about something which you shouldn't.
Yeah. Hey.
Academics, bro, like academics, very frustrated. Even simplest thing, we just cross our minds to think like, yo, there comes horror. So look, sine 250, following the fact that you must make it to relate to 20. Which one would you use for sine 250?
Would it be the third quadrant?
Third quadrant, 270 minus 20, ne?
Yes.
So you say sine of 270 minus 20. Therefore, that would be sine of negative 20 degrees, because on the third quadrant, sine is negative, which is positive. So that's why it's negative, what's on the third quadrant. But sine 20 is opposite over hypotenuse. So that means sine be minus square root of 1 minus t squared over 1. So we don't necessarily have to write them. Just minus square root of t squared. Even if we leave it like that, it is our final.
So in a test, should I draw the diagram even if like thing is 1 mark?
Survive without the diagram. There's no way you can do this question without the diagram. Like, this is the procedure of how it's done.
Yeah. Yes.
Emily, feel proud to draw the diagram on the page where you are answering from. So you are showing them confidence where I know what I'm doing. But otherwise, that's the story, guys. Like you can bring any question, like they can make the t, they can not even give you like, it's just that for when they give you one variable, they can complicate the variables and give you like over whatever. When I just stick to the fact that sine is opposite over hypotenuse, which is y over r. Cos is adjacent over hypotenuse, which is x over r. Tan is opposite over adjacent, which is y over r. Knowing that, you have an already opening scenario. Because do you remember in previous questions, sometimes you used to even decide in which quadrant is the diagram going to be based on, yeah. So now they don't really give you that limitation. Mara, when you get to another grade, it might be that case. Now they bring the diagram, they bring variables also. So, but when you know what you're doing, it's the same as the first step. Just now they are like, now, this should give you a sign for it. Whatever I'm doing is the same thing I've been doing even last year. It's just that they are trying to fool me to think they are more complicated, but it's actually still the same thing. Just putting a level up, you see. Which is the reason why tell everyone that grade 10, grade 11, and grade 12 is just the same struggle. But the world will never believe it. Grades don't matter. But anyway, do you have any more questions regarding this now?
Not that in specific, but I wanted to know like the co-functions. And also if there's an easier way to memorize special angles.
The easier way to memorize special angles
Mm-hmm.
is the practical way. The practical way. So look at it like this. The practical way is you will always remember that sine 30 is 0.5. It's easy to
Sine
memorize.
30.
Sine 30. If you punch
Oh
sine
yeah.
30 on your calculator, it's 0.5.
Is this like the special, not special angles, I meant special angles in terms of general solution basically.
Yes. But for now, I was talking about special angles in terms of 60 degrees, 30 degrees, 45 degrees.
Yeah, that one
That's
is
special.
fine.
Uh, when you say in terms of general solution, special angles in terms of general solution.
Yeah, like how in certain cases, like we get our general solution right. And then when we get that angle, it would be like 0 plus K 360. You get. So yeah.
Yes, that's just general angle. The only way, like, okay, Sharp, this one I can't just hijack it like this. I have to start it from the fresh. Don't worry, I'm gonna do this one. Maybe we can plan for this. Maybe for tomorrow properly. But let me tell you something. There is a specific way to present a general solution. Whatever changes may happen in the general solution, it will be based on what angle did you have. Mara, it's fine. I think I might be getting what you are saying, but it's nothing which I can just hijack the way you see this one. I hijacked it because I knew it's something that you know already. But there's
Mm,
something which we have to go from scratch and say, let's go look at it like this. Because this one
okay.
is just application of the past. So yeah, we can do that one. But any other than that, for this, I hope you have digested this one. This one you will never struggle any
Yeah.
issue. Yeah, this one we can put it aside and focus on the other ones. But it's just a Tuesday today, so we still have time to prepare for your next week. I just felt bad not having a lesson at all because I was busy with my stuff, which didn't even come all right, and I can't wait for tomorrow to try and fix it again. So in my mind, while I'm teaching, in my other thing, I'm like, I'm worried about other things that I'm fixing. It has something to do with my studio. If it works, you guys will be having it a better. It's an upgrade of learning. We keep on
Mm,
if it was gonna simplify my life probably and your life too. Like I don't know, man, but yeah. I'm trying to make learning easy. It's not gonna be easy because it's learning. It still involves question papers. It still involves the work of the school. But that's it. Before I go any further, Jade, do you have any question you wanna ask based on what we're doing here? We're still gonna do it from scratch, by the way. Are you there? I think we're just talking together such that we overshaded other.
which I
Hello.
see.
Yeah, I know. Nah, it's fair. It was just some days it's gonna be about this one. Some days it depends on who's writing. Are you still there on the other side? Your mic is on mute. Okay, fine. Maybe she's not really paying attention. But anyway, yeah, man. In conclusion, that's where we can. So let's rest it from here. Let me just say tomorrow I'll prepare a cool lesson based on general solution. Also to get it over and done with the way we did with this one. Just put it on the side. We know
Can you
what
do
we're doing.
co-functions before tomorrow? Because like some of the general solutions have co-functions, so I would be prepared for tomorrow.
Please send me an ideal question because for now the material would be just to go through a past question paper and then we search for a question that is similar from that.
Okay.
Do you have any ideal? Oh, She can't unmute. Oh, she can't unmute. I was not reading my texts. There's something with the. I'm waiting for the question.
Oh, yes.
Okay.
To take me out of
All right. Go through them one at a time. First page. Okay. If I get this, for the first part, where you would have to simplify something like sine 360 minus theta, it's no longer a problem, right?
let's see if
this part still a problem?
Kind of.
If yes,
Yeah.
let's discuss this part. Let's discuss this part. It will be our final for today because I still want to do something with one student before I sleep.
Okay.
So we say in our Cartesian plane, as much as this is 90 degrees minus 8, this would be 90 degrees plus 8. This would be, because we count from 0, 90 degrees, 180 degrees, 270 degrees. Then
Oh, okay.
which is the reason why when we say 90 minus this side, it represents anything below 90. And it's 90 minus whatever.
Mm-hmm.
So this side, it's a 90 plus because we are adding from 90, but coming from 160, I'm coming from 180, we are subtracting again. And it's also 180 minus whatever. From the third quadrant, we are adding from 180, so we have 180 plus 8. Whereas from 270, we are going back, we are subtracting, so it's 270 minus 8. So from here, we are adding again 270 plus 270 plus theta, while we are subtracting 360 after completing, coming down. That is 360 minus theta. But from 360, we can add going forward again, and now it becomes 360 plus theta. The only special ones here is the ones that involve 9s. There's something special about them. What is that thing? What is that special thing?
Oh, they're cos functions, which means they could equal to cos or sine, depending.
They could cos or sine, but their quadrants still matters. So let's put sine 90 degrees minus theta and cos 90 degrees minus. What do you think this one is going to be?
It's gonna be cos but minus, I think.
Why minus?
Because cos is negative in the second quadrant, whereas sine is positive.
But is 90 degrees minus theta second quadrant?
Oh no, first. So it's all positive, I mean.
So that would be positive. And you are doing very well because you should allow that to guide you. All are positive here, only sine is positive here, only tan is positive here, only cos is positive here. That's the best way to approach it. What would be cos of 90 degrees minus theta?
Positive sine.
Positive sine theta. Now, what would be the other way around? Sine of 90 degrees plus theta as well as cos of 90 degrees plus theta. If you can get these ones right, you are good to go. Sine 90 degrees plus theta. Consider the quadrant while you are giving your answer.
So would it be cos, would it be positive or because sine is positive?
It's about sine, and sine is positive there. However,
So
it still has to change and become cos. So it would be positive cos. It would be positive cos theta because in that quadrant it was about sine, which happens to be positive, although it changed to cos. So what would be cos of 90 degrees plus
would it be negative sine?
negative sine? So you see, you are not guessing it. You are using your understanding.
Because cos is negative in the second quadrant.
Negative. So it was about cos on the second quadrant, although it changes to sine. But since it's about cos, we are just showing the co-function, but it's about cos, and it changes to negative sine. Although sine is positive in that quadrant, but it is about cos. Just by knowing this, you are good because the other ones, they don't change and become anything. You take them as they are. If it's sine 90, it's gonna come out as sine 9. If it's maybe 270 sometimes can do the co-function Yanamara for you. For now, let me not put it too much in your grade. Just stick to it may come out the way it is. We're gonna fix it when we get there. So
Wait,
now,
what was the question?
no, now we are approaching,
Oh,
we are touching on now.
isn't it the same with 270 minus or 270 plus?
Yes, I'm saying we're gonna, hence I'm saying one step at a time. We're gonna do that when we get there. I know that for now you won't have a lot of 270s, but we'll cross the bridge when we get there. For now, we just have enough information to break what we have. So for this, for the 90, let's leave it like that. For the 270, it applies more or less the same similar theory, but we're still gonna come to it. One step one step at a time. So for this, I want you to just one at a time. 360 minus theta, what quadrant is that?
360 minus theta, quadrant 4.
Quadrant 4. And what would be the outcome of the first sine 360 minus theta?
Sine would be negative.
So it would be negative sine theta. And then 90 degrees plus,
Quadrant 2.
and in
So
quadrant, it will be
cos would be positive.
cos will be positive. Because it has to change to cos because it's 9.
Mhm.
Below 90 degrees minus theta,
Quadrant 2. But because cos is negative, it would be negative sine. Ah,
plus 90 degrees minus.
yes, minus sine.
So 90
Wait,
degrees minus is
oh,
first quadrant.
it's positive. Positive, I see.
So that small little sign, it can affect your marks.
Mm,
And cos of degrees minus theta,
that's quadrant 4, but it would be positive.
positive. Plus, and then what would be your final answer?
Um, negative 1.
When all you need, your life must revolve around here for this type of theorem, but also to remember the special case of 90 degrees. We're still going to emphasize on the 271, but for now, let's look at it like that. So I'm just giving you some confidence about your next week test. Don't worry, it's not that much of a big deal. It may seem
Yeah.
like it from, but if we sit down and push those things, it's nothing to worry about. And while we are still on a Tuesday, we have a lot of time to get build up to it. So let me pay attention to my other student who's writing soon also. Jay, don't leave the meeting. Now let's do that graph thing. I don't know how we're gonna hear each other because of the meeting now. Oh, okay, I might do that thing of calling WhatsApp. This is the technology we need to have a backup for everything, guys. Nothing should stop us. Okay, Naliri, it's fine if you wanna exit the meeting.
Okay.
Sure. Thank you so much. We can proceed tomorrow. Hello. can say ku namuntlha a wu tirhisi the normal phone leyi tirhisaka every time ne
Yeah, it's like the previous times, but for now.
tirhisa phone ya na vona but
Yeah.
I think through the call wa swi kota ku accessa screen xa hina still ne
I think so.
yeah as long as you can this part also works too una example ya question leyi u nga na yo ya ka yo directly without having to search for anything instead of not wasting time actually you know what let me close this meeting first exit the meeting takusendela a different link ne all right takusendela a different link I'll call back let me just okay, Ashman, I didn't want to continue with the same lesson on a different thing. I'm done with this one is for the ones who's watching for YouTube, who's watching from YouTube. I need to close this meeting and continue with everything. But otherwise, if you want to join our private lessons, feel free to contact us on 081 465 2676. That's 081 465 2676. Simplified RSA, the guys who makes it look easy. So what we do is we assist with private lessons. Just contact us and find out more how we do it because we are here for you to make sure you get to enjoy your academic journey. For all those things that you think they may be challenging, we're going to simplify everything for you because we are Simplified RSA, the guys who make it look easy.
Simplified RSA, the guys who makes it looks easy. Your number one learning channel.